So in this video, we're going to take a look at how to draw a box plot, what's often known as a box and whisker diagram, and we're also going to take a look at how to interpret them and compare data sets with them. So first of all, take a look at the diagram in front of you. This is an example of a box and whisker plot, and it has 5 pieces of information in it. It contains the minimum value, the maximum value, the upper quartile, the lower quartile, and the median. And before we even get started, we need to make sure that we can find all 5 of these things in any data set. Now, when we have lots of numbers and the data set is large, it doesn't matter too much about our technique for finding the upper and lower quartiles. But when we have a short amount of data, a very small amount of discrete data, there can be different ways of doing it. So let's just define this very carefully. So first of all, we should be able to understand the median very easily, because in this example, we have 7 data values and the median is going to be right there in the middle. So in this case, the median is 7. Also, very easy to find, the lowest value, the minimum value, well, that's 2. And the maximum value, well, that is going to be 13, okay? Now, let's just define our lower quartile. So if the median is 50% of the way through the data, then the lower quartile is 25% of the way through together. Quartile means quarters, and we're splitting the data set into quarters. Now, in the example in front of us, we have this median here of 7. So I'm going to say that the lower 3 numbers, that's our lower half. And so our lower quartile is going to be right in the middle of those 3 numbers. I'll call it LQ for lower quartile, and that's 5. And the upper quartile is going to be 9, okay? And for exactly the same reasons. We're just looking at 3 numbers to the left and 3 numbers to the right of that median. So that's how we're going to work it out if we have 7 numbers. Well, what about if there were a few more numbers? What if there were 8 numbers? Well, if I was working out those 5 values, first of all, the median this time would be right in the middle, so halfway between 14 and 18. So you could add them up and divide by 2, or just figure out what's in the middle of 14 and 18. Of course, the median there is going to be 16. Now, to find that lower quartile, well, I'm thinking about that lower half of the data being these 4 numbers. So I'm going to say that that lower quartile, LQ, is right in the middle of that 12 and 13, so it's going to be 12.5. And the upper quartile is going to be right in the middle of the 20 and 24, so that's going to be an upper quartile of 22. The lowest value is 9. The highest value is 24. Okay, final possibility is something like this. If we had 9 different values, and if this was the case, well, this time that median is going to be 8. And to find that lower quartile, I'll consider the lower half as those 4 numbers. And so my lower quartile will be 25% of the way through, or halfway through those 4 numbers. And that's going to be 3. And then on the far side, to get the upper quartile, it'll be halfway between 17 and 18. That's going to be 17.5 for my upper quartile. Minimum value 2, maximum value 19. So hopefully we can just define that now. There are different ways of doing that, but we'll say that's our way of finding that lower quartile and upper quartile. Right, let's jump into some questions. So in this first example, we're given the information and don't need to find anything. Let's just do the diagram. So the way I like to do these is with 5 lines first, okay? So a line for each of those things there. So you need a scale, and that scale has to be consistent all the way through it, okay? And make sure we cover all 5 of those points. So first of all, the minimum is at 82. So we're going to draw a line at 82. Let's go 4 boxes up. Our lower quartile is at 94. What else do we have? We have the median at 95 there. We have the upper quartile at 102. And we have that maximum at 110 there. So draw our 5 lines. Now, the way to draw these is to connect up those middle 3 and then to join up those last 2 like this, and that blue thing that looks like a giant syringe, that is our box plot, okay? And that is how we do it. Now, we're not asked to interpret this yet, but let's just get into a little bit of the dynamics of what this might mean. So really, your box plot contains information, and it contains how spread out the data is. And so we've got 25% of the data in each of the 4 sections, right? There's 25% in each of these. So we can then we can start thinking about, well, clearly we've got a very sparsely populated area here between 82 and 94 with minimal amounts of data. And then here, look, between 94 and 95, we have a squash. It's condensed. There's lots of numbers there because we have a whole 25% of the data set all squashed into that smaller boundary. It's quite consistently spread out in that second half of the data between 95 and 110, evenly spread with very little difference between the spread of the third and the fourth quarter of data. So those are the sorts of things we can draw out from a box plot. Right, let's take a look at another one. So here we have some values. Let's try to figure out how to find those 5 things we need. So the first thing to do is to make sure they are written in order of size. So let's rewrite them. 1, 5, 7, 9, 11, 15, 22. We've still got 7 values there. Okay, so now we can work out let's call it the lowest value, the lower quartile, the median, the upper quartile, and that highest value. Okay, well, let's do the easy ones first. The lowest value is 1, and the highest value is 22. The median is in the middle, so if I've got 7 pieces of data, that means that 9 is in the middle. Now, to find the lower quartile, we defined it to be in that lower half of data, the middle of that one. So we'll say that the lower quartile is 5, and then we'll say that the upper quartile is 15 for this data set, okay? Right, now we've got the things we need. We can put them on our scale. I've already pre-drawn this scale. You might have to do this yourself. Just make sure you cover all 5 values and you're going up by the same amount each time. So I am going to mark across a line at 1 and at 5, at 9, at 15, and at 22. And we can join them up in that way. And there we are. We have finished our box and whisker diagram, or our box plot. Let's take a look at how we can use them now. So a gardener collects data on 2 types of tomato. The box and whisker plot below shows data for the masses in grams of the tomatoes in the 2 samples. Compare and contrast the 2 types and advise the gardener which type of tomato he should grow in the future. So first of all, we can clearly see that this dotted line is in the same place for both of them at 52 grams. So this means the median, the average, is the same. So on the surface, perhaps, there is not much difference in type A and type B. They both come out of the same average mass in grams. However, there are some differences between the data set, because clearly we can see that type A has large spread of data. So they have the very smallest plants down here at 46 grams and the very biggest plants as well at 60 grams. So there's a huge variety in type A, whereas type B is much more consistent. They're squashed together. Everything's between 49 and 57 grams. So if you were cooking and wanted to have consistent tomatoes, or you were selling them, perhaps you would choose type B. However, if you were aiming for a competition, who's going to have the biggest tomato, then perhaps you would opt for type A, because type A generally looks like it will create the biggest tomatoes as well as the smallest tomatoes. Okay, so type A is perhaps contains the biggest, but type B is much more consistent. I would advise, without any other information, that the gardener goes with type B. Let's take a look at another example. A builder can choose between two different types of bricks that are coloured red or yellow. The box and whisker plot below illustrates the results of tests on the strength of the bricks. From the data illustrated in the box and whisker plots, give a reason why the builder might prefer red bricks. Well, the builder might prefer red bricks because if we compare those medians, the red bricks have a higher median, meaning they are stronger on average than the yellow bricks, perfect for building a house. So they have the higher average. B, give one reason why the builder might prefer to use yellow bricks. Well, because right down here we can see that there are some very weak red bricks. And if you are a builder building a house and we're building one layer on top of the next, we don't want any weak bricks at all. So perhaps we would pick yellow bricks because they are far more consistent and reliable, and we don't get those weak bricks mixed up with those strong bricks. Okay, I hope that helps you to understand box and whisker diagrams, and you can answer the questions.